Good evening. So I'm audible now properly.
Yes, yes, audible.
Is my video visible?
Yes,
And the last check, is my screen visible?
yeah, it's better now.
Okay, great. Sure. I hope there is no glitches this time.
There are glitches. There are glitches. I see the screen is fading a bit.
Oh, is it? Okay.
Is it same for you, Manugna?
Yeah,
Uh, okay.
Sure. Like, is the code visible?
Yes, it is visible
yes,
now.
yes, yes.
Okay.
Arya, is it possible like you if you turn off the video, then the bandwidth will won't be distributed and the video, the screen share will be clear.
That makes sense. Let me just try. Let's just wait for like 2 minutes.
Mhm.
So I'll just explain the theoretical concept here.
Yep.
And then if you got any glitches, yeah, please tell me. Okay. I just changed my network. So let's check. Okay. So yeah, anyway, let's start from the beginning. Okay. So we were revising on like yesterday's, right? So we were revising on yesterday's steps. So that is we discussed on like APIs. So the API status codes, what do they mean? And we checked on like with API securities and also HTTP methods. So earlier we were discussing on OOPS concept and APIs. This is what like it's been like for 2 days. Okay. So yesterday we checked with like all the concepts of OOPs available. So classes and objects, day before yesterday we discussed, and all the polymorphism, inheritance, abstraction, and encapsulation. I explained it yesterday. Okay. So those were theoretical concept. I explained it. So with the example, I did give an example, but let's try to look them like through code. Okay. As of today, right? Sure. So I hope my code is visible here. So there is a class called LLM tester. Okay. And there is an init function where it is expecting two elements majorly, that is API's URL. So whatever the URL we want to hit, and then the model name. Okay. Then there is an like function ask model. Sorry, this is a method within the class that is ask model. It is expecting prompt. So once we provide the prompt, this will set up a payload and it will request to the given URL the payload. Okay. So whatever the response comes in, it will show us it will return the response if there is some errors. Okay. So those errors will be handled here. All right. So any doubts with this?
No.
So yeah, this is my local host link and this is the local Llama 3.2 model. So you guys know that I do have that model. So let's check. Okay, and try to print the response. Yeah, that's great. So let's just try to run this particular class. So system initiated tester for Llama 3.2. Mhm. So tester one became the object of LLM tester class. So we are passing the URL which has been asked, and we are passing the model name Llama 3.2,
Mhm.
correct? And then we are pinging the method ask model method with a prompt,
What is the
right?
capital of France? Okay.
Yes.
So
Okay.
that's the prompt.
Yes.
And
So
ask
then
model
we are printing
accepts
it.
a self is a current class object and a prompt. So we
Hmm.
are passing the prompt here.
Okay, right. So here, whatever the response may be here, if the LLM call is successful and the response is actually the response from LLM, then the whatever so this method will return the response itself. Okay. If not,
Mhm.
what it will return the except like error, whatever happened. So here as you can see in the AI response. So here there is error. So this is what the response came in. Okay. So
Mhm.
Llama runner process has terminated. Okay. CUDA malloc failed out of memory. Okay, loaded model, unable to allocate. Okay, so my system is unable to actually allocate memory in order to run that model. That is what the error is. Let's
We'll
just
try
read.
with the lower model.
Um, so all the models I have are usually of the same size. So I
Okay,
doubt like
okay.
if other model will work.
1B
Well,
is
then let's
also there,
just
na?
read.
Do you have 1B model?
Not actually.
Okay, okay.
Okay. Yeah, the same error. So what we need to do, like if we face such, just restart your laptop and they should work. They should work. Okay.
Acha,
So yeah,
since it's occupying your all your space, it's referring to CUDA. So must be your graphic card is not having the capacity right now.
right.
Can we check the graphic card usage right now, like of your system? Like it must be full, I guess, but let's see.
So sometimes even in the performance tab, you
CPU,
won't see like graphic card to be zero itself.
GPU, can you come down to the last tab? Acha, GPU, okay.
No, this
See,
is the GPU. Actually.
this is the GPU, yeah, and it's
Yes.
zero, is it like 0%?
Yes. So the
Okay, okay.
memory, as you can see, it is zero in the utilization tab. I have observed this. Even though it is shows zero, sometimes it doesn't load. Okay.
Mm-hmm.
So there could be
Okay,
some so in background there could be some string which is like stopping the execution of this GPU maybe. Okay.
okay. I see your memory is full, that RAM, I guess. It's 90%.
Mm, right. 16, 93% or right, yes.
And under the processes, which is consuming the most process? Is it a Llama related thing?
So we have to check with like I have like a lot of tabs open. So
Google Chrome. Oh, okay, okay, okay.
yep, the Chrome is consuming most
Chrome
of
is
it.
consuming.
So this is usually the thing, Chrome and Edge, they
The
consume
tabs. Yes, yes, yes.
so the background process. So if any of these background processes are restricting uh,
They're zero, zero, zero
the load,
percent. Max 0 points. All are zero.
yes. So it actually like it doesn't completely depend on utilization. Okay, if there is some
Mhm.
process which needs this resource,
Deadlock kind of thing.
yeah, if that happens, right? So even then our model just doesn't load. So the best thing would be like to restart it at that point.
Restart. Okay, okay, okay.
So for now, yeah, let's not just go with that method, but I will try to explain the things. So here, the main agenda was to like, we have seen the LLM response already, right? So it's been like so many days we are seeing the LLM response. So what we wanted to see is like, is the exception is being handled? Okay, the try except if it is doing the work. Okay, so it is doing the work, right? So that's first thing. And through this, through the object of this LLM tester, are we able to ping this ask model? Is that being done? Yes. Okay. So there is no error in the first line. In the second line, yeah. So it is pinging the model, but the model is not responding. That's why. So it is pinging the method, and within the method, the model is not responding. That's why it has been like it is accepting the exception happens, and that error is being printed, right? So our LLM code, as per the oops, it is running fine. Understandable? Yes.
Yes,
So
yes, yes.
no worry with the LLM response. We have seen LLM response. But here it was more of like Pythonic way of like trying to look at the things. Okay. So that is successful here anyway. So moving ahead. So we explored like what are the elements we are discussing here. There is a class, there is an object, there are methods. Okay. And okay, let me show you something else to here. So let's just say let's make the model name to be private. Okay. So let's make it a private element. So let me just run this. I run this. And now let me just try to run this. Now is equal to 3.2. So this shouldn't have that case. Maybe we don't have to send this particularly. So let's just try without. But it's just right. And this tester one here, tester one dot. Okay, so we can access API URL. Okay, this is like instance, right? So yeah, so whatever the variables you are creating within this class, if it start with like something like self.api URL, right? So this becomes instance variable. So if you create some other variable, some other object called tester2, and you assign different API, this link, different endpoint and different model. Okay, so when you try to access these particular variables, so whatever it is associated with that particular object, it has to be shown. Okay, so let me show you. So let's just say here tester2. So just putting something 5.3. Okay, 5.3 is the model here. Let's just run this. So now if I type like tester1 dot, we're checking on the model, right? API URL is same, the model name. So when I run tester1 model name, it has to be Llama 3.2 because Llama 3.2 is the model that's been associated with like tester1 object, correct? So when I do tester2, so this should access this particular 5.3, right? So but that's why. So these particular variables, we call these variables like instance variables. Okay, whatever self dot variable name we have written, right? So these are instance variable. So if there is some variable in LLM tester, okay, let's write up universal model. Universal model is the name, and here let me say not Llama 3.2. It's OpenAI. Okay, that's so let's just run this. Yeah, it run. Let's just run this. Yes. So here doesn't matter whether it's tester1 dot the universal model name, right? So it doesn't matter which tester I use. So for both, this is common. Okay. For any object that's been defined under this class, the universal model names. So this variable contains only OpenAI GPT-4. Okay. So this is the difference between like this is instance variable, so dependent on object. So this is class variable. It is dependent on class. Make sense? Okay. So yeah, that was one thing. I'm still surprised on. So here I am running tester one and tester two again, and now I'm trying to access universal model. So LM tester object has no attribute universal model. Okay, so that's why. So we have to put like underscore here, then this works. Okay, but in the suggestions it shouldn't show us like universal model, right? It is showing us. So I'm not sure like usually. So if let's just say self.api URL, right? So if I make it private variable, so this shouldn't be shown like in recommendations. Let's try with this model name. Okay. So this is what we studied on the encapsulation, right? So one dot. Yeah. So we just lost the task model method, correct? So this isn't showing like in ask model. So if this wasn't like public method, it should have shown like here the ask model. But since it is a private method, so it is not showing us the ask model. But the same concept should have been true for the variables again. So we'll check on like why it is not operating on system like instance variables. Maybe I'll explain it like in tomorrow's class. But yeah, for methods it working, but for instance variables it is not. Check and get back. Okay. So that is all. Like for encapsulation, that's visible here, right? So let's just go with like another example. So here we have a. So any doubts there? If not, we'll move on. Okay. So yeah, the second example. So the class is device. Okay. So this is a classic example of like, let's say inheritance. Okay. So my device has a method called power on. Okay. And the init, it is expecting a brand. Okay. So yeah, and we have another class that is smartphone. Smartphone is also devices, right? So smartphone is inheriting the device class. Okay. Parent class illustrate abstraction and encapsulation, right? So here the smartphone class is inheriting the properties of device class. So now it has got like brand and model. Okay, so brand and model, that's fine. So we have power on method here too. Okay, so the class, there is another class called laptop, which is also which also inherits like device class. Here we have other power on again. So the same method, you can see the same methods, right? The method name is same. Okay, but what it is returning is different. So here it is only returning self.brand. Okay, whatever brand we are passing, we are just, it is just returning this. But here alongside like the brand, it is returning model. Okay, so here again the brand. Okay, uh, so let's just try to execute it, and the response we may understand this better. So first we are considering a variable devices. So here, so yeah, this is a variable devices, which is a list actually. Okay. So within the list, there are two elements, smartphone. So this could be like, if you try to initiate it, this could be an one object. Okay. This could be a second object. Okay. So here what we are doing is for D in device. Okay. So what it does is, so D in device in the sense, so it will iterate through these objects. So iterate through the elements. It doesn't know whether it's an object or not, right? So everything in Python is object itself. So this is the first element and this is the second element. Okay, but we know these are objects. This will create an object. Okay, so here what it is doing is for D in device, initially it takes smartphone, Samsung S24. This is like device brand. This is model name. Okay, so here it is printing print D dot power on. So for the first time, so smartphone is being pinged. So the class smartphone expects two elements, that is brand and model. So brand and model is being passed. Samsung S24, correct? And then, so now once our smartphone is being passed with the brand and model name, right? So this brand is also being initiated to the parent class. So the child class can inherit the things from the parent class, right? So they have a connection. Okay. So then the self-dot model, okay. So we have power on a method here. So this power on method is being written. So that's why first time it will print brand and model name. So that's why. So this is a print statement. So at initial first time, it is printing the brand, the model name. Okay. Is booting the Android. Okay. Let's check on like where it is there. Yeah. Phone is booting Android, correct? So this is being printed. And next, we have laptop. Okay, so once smartphone is done, D actually contains like laptop now. So D dot power on means laptop. That is Dell is being passed. So in the laptop, it is expecting only or self dot brand laptop is loading Windows. Hmm. Okay. So yeah, here there is one more learning here actually. So here you can understand this smartphone class, right? So this has got power on method, and there is another method that is init method, right? So since this has a init method, it has its own like the elements, brand and model, and we are passing it, right? But as you can see, laptop inherits like the device class, but it doesn't have its own like init method. So whenever a class which any a child class doesn't have a init method, right? So this init method, if it doesn't have a init method, it actually follows the init method that is present in the parent class. Okay. So now since this class laptop doesn't have a init method, it actually follows the device init method, whatever the init method is defined under the device, right? So it has to follow this. So that's why even though we are not expecting any input here in the like laptop, right? So there is no input method, so we are not expecting any input. But here we are passing the input that is del. Okay, so what it is doing is, so it is inheriting this particular init method, and within this init method, parents init method, so brand is expected. So that the del is being passed here. Okay, so what this returns? It returns the brand name laptop is loading. Okay, so now you can see Dell laptop is loading Windows. Make sense? Any doubt here? I guess I missed this like while explaining inheritance. Yeah, we got it covered now. Guys,
Yes, yes, yes. No doubts, no doubts.
Are you following this?
Yeah, slowly relating to the things. Yeah.
Simple thing here. So
Mhm.
this parent class and child class, they have a connection. Okay. So whatever the parent class have, so the child class will automatically have it if it has got its own thing. Like so it's just like parents suggest and we do it. Okay. If we have our own thoughts, we don't listen to parents, right? So this is like smartphone is inheriting from the device, but it has got its own thought that is in it. Okay, it has own it. It has already got in its init method. Okay, so it is doing its own. Okay, but as of laptop, it doesn't have its own thoughts. Okay, so it what it is doing is, so it is doing whatever suggested by like parent. Okay, it is following parents init method. Parents init method is actually expecting brand, so it is also we have to pass brand name. Understandable?
Yes, yes.
Yeah. So yeah, that's with that. So in the for loop, so we explore like smartphone and laptop, both the classes. Okay, and then we have second one encapsulation. So it's smartphone, Google Pixel. As you can see here, we can understand one more thing here actually. So you can see all the three classes have the same method name, correct? Power on, power on, power on. Depending on like uh, which object is calling this power on, depending on which is the class that object is of. So this power on, what it is printing is changing, what it is returning is changing, right? So that's why when it was smartphone, it was saying Samsung S24 phone is putting Android. Okay. When it was like laptop, it was like Dell laptop is loading Windows, right? So we have again phone object. So phone is a variable, okay, which is the object of smartphone class now. So we are passing Google as a brand and Pixel as a model here. And here, what it's printing, we are printing phone.brand. Okay. Brand is common on all these three classes, but still, so since phone is connected to like phone is an object of smartphone, so the brand Google is being printed here. Understandable? So that's the example of encapsulation. So if we try to access something which is not there, so it will throw me like attribute error. Okay. So it will throw me attribute error because it doesn't exist. So yeah, that's fine. Here. Oh, sorry. Sorry. So we do have in the device class, in the init method, we do have something called serial numbers. Okay. Let me try to run this. Let me just remove this thing. And device one is my Okay, so it is of generic brand. Okay, let's just say. So now I'm trying to print brand of device one brand. Okay, so now just try to run this. So the last line, so we are printing generic brand now, correct? So let's try to print some more elements here. That is print device one version. Okay. So the version is, so by default, the version we have mentioned it as one. Okay. So that's why version is being printed. Okay, the version is visible here, all right. So let's try to print what's now serial number, right? So here, if you remember, we discussed on name angling, correct? Something called name angling, if you remember. Okay, because although we do have double underscore serial number, so because of name angling, so we can't access it like this, right? So yesterday we discussed this. Yep. That's with a real life example. So this is polymorphism. So the same name are across like all the three classes, but still depending on the object of whichever the class is, right? So the characteristic is different. Okay, this is polymorphism. So we are able to make it protected and private, that is encapsulation. And what else did we have? So yeah, abstraction without worrying about like what this power on method does. Without knowing the code also we can call it, that is, sorry. So that is abstraction, inheritance, we are looking at it, okay? Make sense?
Yes, yes, yes.
Sure, we will quickly go to like, what's today? Okay, right. Okay. So yesterday we discussed on something called try except block, right? Okay. So we discussed something on try except block. So here we were managing. So if this try block runs successfully, except won't run. If some exception happens here in this try block, so the exception will run, right? So we had finally two. So which will automatically run, doesn't matter if try successfully manages or exception occurs. Okay. Finally will always run. Okay. So this was the try except block we discussed. So this is good. But what if, let's just say, you are trying to ping an API. Okay. So there is an like OpenAI API, and you are trying to uh, put up your prompt to this API, and you are using your laptop, and there is no internet. Okay, or maybe there is an internet, but the connection is not like completely stable. So in the first try, you may get it. In the second try, let's just say you are putting up like 50 injection prompts and checking how resilient OpenAI is. So the first prompt goes successfully because internet was there. The second prompt, it may go or it may not. Okay, it may reject because of the connection error. So you may get the third prompt. So what you do is with the for loop, when you say for I in prompts, so prompts could be like list of all the prompts you want to use. So let's say you are using request library and you are passing the model name, sorry, endpoint. Okay, there is some endpoint and you are passing your prompt or payload. Okay, so you're passing this information. So this request library actually pings one by one. It takes your prompt in the prompt list. So prompts could be your list where first prompt is there, second prompt is there, third prompt, and we have like 50 prompts. Okay. In the for loop, you are putting up and you are passing this request and you are recording all the responses. Okay. So whatever the response comes in, you create one more list called responses, and within which you are appending all the responses. Okay. So this new list contains all the responses for all the 50 prompts. Let's say you don't have a stable internet connection. So first prompt gets successful, second prompt throws up an error, or maybe OpenAI is sending back a message. Okay. Or there is something that's being happening here. There could be an error. Okay. And the error is being recorded as a response. So for the first response, you have a complete response. For the second response, you don't have a complete response, you have an incomplete response. This could be an error that's being recorded. But in the list, you think all of these are responses, correct? So let's just say among the 50 requests, 24 maybe like accepted, 26 are like denied. Okay. Or let's just say 24 accepted. There are certain like 24 which got denied because of the connection error, and there are two which got rejected because of like token limit or something. Okay, this can happen, right? Guys, are you understanding what the problem I'm trying to explain? So
Can
with
you
the
explain once again? Can you explain once again?
okay. So let's just say, so like while checking on the prompts, like prompt injection or something. So there are set of prompts you have got, and you want to check like for all, right? Not manually. You want to like write up the prompt and check it like how the response comes in and the second prompt comes in. You don't want to do that, right? So you have this
Yes.
set of prompts and you want to ping it continuously and check with the responses later, right?
Mm-hmm.
So let's say you are using a for loop for this. Okay. So this list contains prompts. Prompts is the list which contains like 50 prompts. And you are using a for loop to actually consider each prompt at a time, and you are trying to send a request to this particular OpenAI endpoint. You are passing the endpoint and the prompt.
Mm-hmm.
Okay. So now it is trying to ping the server, OpenAI server, and it is trying to get the response. Sometimes, okay, so let's just say you have an unstable internet connection. So sometimes there is a successful like interaction happens and you get the successful response. Sometimes you may get an error that there is a connection error. Okay, connection couldn't be possible or something like that. Okay, so everything is being like considered as a response here. Okay, if you create a try except block, okay, first operation happens. Let's just say first thing was successful, second thing was unsuccessful. So
Uh-huh.
except actually handles it, and it actually stops the execution of for loop, correct?
Yes.
So this could be a problem, right? So you want to checklist this 50. So you want a mechanism, okay? You want a mechanism which actually retries for certain times before actually like asking you to like handle it, or let's say throwing up an error, right? So you
Yes.
want certain mechanism which actually retries before actually confirming that this is not working. Let's just say it may be like as minimum as 3 times or maybe like 100 times. Doesn't matter. So using this try except block is cool. Okay. So you are handling the exceptions that comes in, but you are not retrying it, right? So if once exception happens, so that's done. You're getting the message of exception, that's it. But in LLM call or any API call, leave out of LLMs, any API call, there could be any number of things that may go wrong. It may be your queues, so many requests, or maybe token limit reached, or maybe wrong API key, or let's just say there could be connection error, or there could be like too many request error, right? There could be like multiple type of errors that comes in when you are interacting with an like API on cloud, correct? So you don't want to catch this. So yeah, we are trying it. You are catching the exception. That is good, but you wanted to like you want some retry mechanism which actually retries for certain amount of time before actually responding with the error message. Okay. So we will check on like how we can use this mechanism, and if we have something in Python which actually does this for us. Okay. Yeah, that's what I can explain here. So junior engineers code for when the things go right. Senior engineers spend 80% of the time coding when things go wrong. right? So average cases, anybody can handle it. Anybody with a small, like who knows coding can handle average cases. So it is about handling the edge cases. That is where the seniority comes in, correct? So that's what being explained here. So what happens if a network blinks during like prompt 42 or 500 test suite? Okay, you are trying to create an automated test suite of 500 prompts, and somewhere 42 or 40-second prompt actually fails. Okay, it doesn't get response. So how it is handled? In try and accept block, you get 41 responses, you record 41 responses, and all the other prompts you have to retry again, correct? So that you don't want to do it. So let's just say there is a crash. Without resilience, your script throws a connection error and dies. Okay. All the progress that's being recorded. Okay. So if there is an error, it is not handled, let's say you have lost everything, whatever you recorded, all the 41 successful prompt responses. The solution, we must build a indestructible pipeline that can survive small errors like this. Okay. So maybe network error or certain errors. So how we can build? So yeah, API usual failures, too many requests, timeout errors, or service unavailable, or API request. API key is wrong, or yeah, there is an like method update. Okay, so all these could result in like API failures. So here is the safety net. Okay. Okay. So yeah, I will just get back to code. Okay. Is the code visible, guys? So we have, it's visible, right? Hello. Hello. Hello, Saurabh. Manavne?
Sorry, I think my internet broke in between. Yeah, I'm back. What is it?
Yes, yes, Arya.
Okay.
I
So I
I
thought
was
it
on a
was my
call.
internet. Sorry.
No,
Okay.
no, I was in a call, sorry.
Okay. Okay. All right. So is the code visible here?
Yes, yes, yes.
Okay. So yep. Okay. Before this, I have something prepared here. Just a second. Yeah. So yeah. So is this code visible? I hope it's visible. Uh, so let me just try to yeah. So I wanted to explain about this Tenacity. Okay. So this is a library. So yeah, which you can use in order to retry, in order to actually use this retry mechanism I explained on. Okay. So let's just say, okay. So let's just say you have a function that is called LLM API. Okay. So you have this function call LLM API, and what it is doing is it is actually printing. It is doing nothing. It is actually printing calling API. Okay. So and it is also printing the current time, whatever the time local time is there, right? So that is it is printing the local time. Okay. So yeah. So this raise connection error, is it visible? So what it is doing is So if there is no error, sometimes if you want to create an error, okay, you can use this raise keyword. Okay, so whatever the error you want, you can mention it and it will throw up an error with this with a particular custom message you want. Okay, so this usually happens. Let's say senior management has given us an like boilerplate code. It doesn't want it won't they want us to like as a junior developers, they want us to like operate on certain domain. Okay, so under certain restrictions, okay, they may set up such rules. Okay, so here what we are doing is we are calling this API. What this API is doing is it is printing two statements, that is the time, and it is saying calling API. That's it. And in the third line, it is actually raising a request. Sorry, it is raising an error, that is connection error. Okay, let's just try to run this, and then I will explain how we are handling it. Maybe like let's run it for 3 times. So yeah, I will call this function now. Okay, it showed me an error, but before error, there are something is being printed. So let's check on like what's being printed here. Okay, so Thursday, May 7. Okay, so today's date 16/23/26/2026. Okay, so this is a timestamp that's been given. Let's just say, and in the second line we have calling API. So calling API is printed, correct? So in the third line there is an error. So this should create an error. That is what the logic is. So as you can see, since we are retrying it this 3 times, so although there is an error, it retries the whole function again. Okay. So again, the timestamp is being printed and then calling API is printed. And the third time also it's being printed. And third time, since it was the third time, so it actually gave up and it like showed us whatever the error is. So that's the connection error which we have created for ourselves. And the message is, yeah, API is down is the message. Correct, guys? There should be some questions here.
It's uh, taking time to process.
Okay, taking time to process, like, is it like
Like
my
we,
network or
no,
this
my
function?
our understanding, our
Oh,
understanding.
okay, okay. So what's happening is, so this third line, so with actually creating this request, right? So let's just say I'm removing this connection error. So let's just remove this and let me explain this raise connection error, whatever is happening.
Mhm.
So when we run this code and when we actually try to run this function, so it is running, the first line is printing the time, right? That's being printed. The second line is printing calling API. So that's being printed. In the third line, it is actually raising a connection request. If we don't have this code, it actually runs successfully. Okay. There is no error with the code. But by writing this code, we are actually trying to
Mocking the
say,
failure, is it?
yes, yes, yes. So we usually have to do this for certain instance. Okay, if you want to like, if you know the edge case and you don't want to hit it, you may create like for your custom error, you can create it. Okay, let's just say you are creating an application for your students and you are like creating this application for some college students, and you have to restrict it somewhere, right?
Yes.
So you
So
can't use.
Arya, I want to
Yes.
understand here that at retry, that annotation we are using here,
Mhm.
is it some kind of framework? Like I remember this kind of thing comes from a kind of a JUnit or something. So
Okay.
when we are working with Python, so how at annotation are coming and how many annotations we have, and like I'm seeing it first time.
Okay. So there could be like different this annotation comes in, and these are actually
Mhm.
called if I remember correctly, they are called property
Yes,
or
yes.
okay, I'm not getting that word. Sorry.
Okay.
Okay. Yeah, I will explain it. No worries. It's just I'm unable to get that word.
Mhm.
Okay. Yeah. So as of now, let's focus on this particular function. Okay. So this function, we are raising a connection error, and this has to like once this function runs, right? So the third line should throw up an error, and usually that should have happened. Okay. So now this will throw up an error. Okay. This at retry, this does is, okay,
So is it like call LLM API method? This is checking like the retry, what we have a retry. It's simulating a loop uh, for the method, and
correct.
it's checking 3 times, and that stop after attempt is a method of error annotation.
Right.
When to stop. And
Right.
what we are doing is just we are printing the time. So it is like for first iteration API down, but it will not print that. It will try again. Second iteration API down. It will not print it. It will iterate again. Third
Right.
iteration it's again API down. So third time it will print API down.
Exactly. So that's what's been happening here. But so how it's happening is, so we have a library, we have a model called like Tenacity, which we
Hmm.
are using. So here we have imported a retry from Tenacity, right?
Hmm.
So we are using this retry wrapper. So we are wrapping this function under this retry. Okay. So what this does is,
Okay.
if the run is successful, let's just say there is no error. Okay. In this case, it will not
It
operate.
will just once
It will run once, and that's good. That's good. If there are
call an
certain
API.
errors, okay, if the function call is unsuccessful for some reason, then it tries to retry this particular function call again and again for, let's just say, 3 times. But here you can see. So let's just run this. So here you
Arya, I
can see.
want to understand this here. Let's say third line is a error.
Right.
First and second line is still a still running,
Right.
but it's not printing that.
It is
Why?
printing, right?
Is it? It's printing. So is it
So it,
printing 3 times? Three. Okay,
yeah, yeah, it is printing 3 times.
3 times. Okay.
So here, after this line, color calling API, there is an error, but it retries.
Mhm.
That's why the first line is printing, it printed again, the second line goes again, and then again the error, right? So it retries the third time now.
Okay.
And at last, since it exhausted like number of attempts, it just throws up like whatever the error is. Okay. So here you can see the timestamp actually. So it is 16:29 7 seconds. So 16:29, yeah, 7 milliseconds. So you can see like it is not giving up even so all of this is happening, all of these retries are happening like instantaneously. Okay, there is an error, let's
Yes.
retry. Right. There is
But
no
there is
time
no
gap.
sense of trying again. Like if let's say if the it does a network lag, is a
Yes.
server lag, then it makes no sense of retrying it frequently. At least it should wait for 10-20 seconds.
Right. That should be the
Server to
case.
settle up. Yeah.
Yes. So we have certain parameters which we can tune here.
In
So
that
let's just
retry.
say,
In that retry
yes.
annotation.
So
Okay.
here
Okay.
we have called wait fixed, right? So what this does is, okay, so I have made it wait exception. Let's just study about wait exception, and then we will look into like wait fixed, what it is. So we are passing a parameter wait, okay, and we are passing some method called wait exceptional, okay, sorry, exponential.
Exponential.
So what this does is, so it takes up like whatever the multiplier is, and then so with the minimum value it multiplies to this particular multiplier, and the max
Mhm.
is 10. Okay, so this is in seconds now.
Kind of a loop. 2
Right.
multiplied by
So
2, 4. 4 multiplied by 2, 8. 8
right.
multiplied by 2 is 10, 16. So stop there. No 16.
Yes, the max is 10, so it considers 10. Okay. You can see here now. So the first and the second, in between, it is of 2 seconds. This is of 15, this is of 17, right? So it waited
Mhm.
for 2 seconds before second attempt. And then, so this is 17 and this is 21. It is of 4 seconds, correct? So let's make it like more, instead of 3, let's make it 6. So this will be like a visible difference.
And after multiplied, there's a max, no? Can you make it uh, uh, 30?
No needed.
Like,
Like, so 30, we have to wait for like 3 minutes in order to get the response. We don't want that, right?
okay, but 2 multiplied 2, 4. 4 multiplied
Yes.
2, 8.
8,
8 multiplied 2,
16.
16.
But 10 is the
Multiplied 2,
max.
okay.
Here 10 is the max. So it considers 10.
What is 10?
So 10 is the
10 times.
maximum number of seconds. Okay, so it can go infinitely multiplying, right? So we are mentioning the maximum time it can wait for. Okay,
But in this
so
case, 2 multiplied by 2 becomes 4. 4 multiplied
yes,
by 2 becomes 8. So 2 iterations so far. 8 multiplied by 2 becomes 16. So, but max is 10. So only 2 iterations has to be done, right? Why
no,
6?
it tries to calculate, but whatever, if it is like exceeding the max, it considered max value. So let's just look at this example and we'll understand. Okay.
Okay, so
So
every
as you
time it
can see,
consider max, like
yes,
when
yes,
8 multiplies by 2 becomes 16, it still waits for 10 only.
right.
Next also 10. So last 3 must be 10, 10, 10. 57,
Yes,
7,
that should be
17.
the
Okay.
case. Let's just like look at
43,
it. Okay.
45, 49. Okay.
So it waited for 43, it's 45, right? It waited for 2 seconds and then it is
Seconds, and then
49.
that must be 4 second.
Yeah,
4
this is 4 seconds,
and then
right?
after 4 that must be 8 second. 49, 57,
Right.
8 second.
It's visibly 8, right? So 49 plus
Okay,
8 is
5th.
57.
Okay, and then
Then it
2.
went for like
10,
only
10,
10
10.
seconds. And
Okay,
again, the 10
got it,
seconds, right?
got it.
So this wait exponentially, what it is doing is exponentially increasing the waiting time. Let's just say our open API call, right? Sorry,
Mhm.
OpenAI's API call. So usually what it does is, so if there is some error, okay, we have to wait for a while. Okay, if there is an error like for 4 seconds, after 4 seconds we are requesting. If there is still the error, we wait for like 8 seconds. Usually,
Mhm.
whatever the if we are on internet and there isn't like rate limit or per minute late some rate limit restriction or some restrictions kind of like token limit and everything, right? So that time this is very useful, waiting exponentially. Okay, so
Yes.
yeah, so we have something, yeah, this is the case. And we have something called wait fixed. Okay, what this does is, so let's
It's
pass it like
explicitly
two.
wait for given seconds, I guess. Every time
Exactly.
2 seconds.
Yes. So that's the case. 25, it's 27. Now it should be 29 and 31 and 33, so on. Okay. So what
Okay.
this does is it exactly waits for like how many seconds we actually pass it. Okay. So that's the difference between wait exponential and wait fixed. So this retrying mechanism works great if we are like have some external API calls in our application, right? So wrapping up this retry from the Tenacity is great way to make it a production ready code. Understandable?
Yes, yes.
Yes. So we have retry. So this stop after attempts. So it is considering the number of attempts. So if that exceeds the number of attempts, yeah. So whatever the error is there, it will show us. Okay. So it at least retries till that point. So that's the simplicity of this. So I just use this simple code in order to make sure you understand this. So let's go with like one of the examples I've taken. Okay. So here what I have done is like yeah. So for now, I'm unable to connect to my like local model, right? We've seen it like earlier. Let's just say usually it doesn't happen, right? So we can connect to our local model. Let's just say we are connected to our local model, but I wanted to show you guys like if it is connected to local model, I usually don't get errors, right? So I get the response directly. So here my agenda was to like randomly create some errors, okay, at some attempts and show you like how this handles those errors. Okay. So here in the example here shown, right? So here all the errors that's like all the error, it could be like connection error or it could be any value error also. Okay. Even if it was like value error, it would have like considered this. No worries. Let's just wait for it. Okay. So we are considering any errors here, but we can specify the errors. Let's just say if it is a connection error, then only just do it. If it isn't like you have exhausted token error or rate errors, okay. So trying for like next 1 minute is like of no use, right? So retrying is not necessary there. So depending on the error, we are writing like custom logic. Okay, that also we can do it. So yeah, here value error is being shown. So whatever we are raising, whatever the error we are raising, so that is being shown there. So here in this code, so you can see like I have used random module and I have used like time model to record the time and present it, and I have used request model to request it like a HTTP request. Okay, so I used all the Tenacity methods which we explored earlier. So there is a class simulated rate limit error. Okay, there is class simulated connection error. So we are putting up our setting up our retry wrapper. That is, so we have stop parameter. We are stopping the things like after 5 attempts. Okay, so in the wait parameter, wait exponentially, multiplier is 1. So we are waiting for like exponentially once it reaches like 10. Okay, then we have retry if exception type. Okay, so here we are mentioning the exceptions. Okay, we are conveying a message that if these exceptions actually happen, right, then only retry. If not, there is no need to retry. Okay, that is simulated rate error. So we have defined it here in this class. Okay, and simulated connection error and request.exceptions, request exceptions. Okay, if this error comes in, then only retry, or else there is no need to retry. That we are mentioning it here. Okay, so we have a function called call Ollama with chaos. Okay, so here we are passing a prompt, and there are few print statements that's been printed here, and I'm rolling a dice like random.random. It creates a floating number, some number between like less than 1, 0 to 1. Okay, so this model, if it is like when it chooses a random number, right? If the number is less than 0.3, then I'm creating this simulated rate limit error. I'm faking this error anyway. Okay, if the random number that's chosen is like less than 0.6, okay, somewhere between 0.3 and 0.6, then I'm presenting it as like simulated connection error. If not, then I'm actually requesting it to my local Ollama model. And if I get the response, then I'm printing the response. If not, we are like, however, we have done like try except block. So whatever the error comes in, we will print it. So most probably there will be no successful attempts for our instance now, because as we've seen, our model is now getting loaded, right? So let's just run this. Okay. Okay. So yeah, so the run was complete. So the our method was able to get the response, that is the success message that's visible here. First time, maybe it was like simulated socket timeout error. Okay, maybe the random number was something between 0 and 0.3. Okay, that's why this error got happened. Okay, so it retried. In the second attempt, it got the response. Okay, it is putting up. So what's the response is? The response is actually error. Okay, so it's catch the error. So since we didn't mention this particular error, so that's why it didn't retry. Okay, so the Llama 3 is not found. Okay, so our model doesn't have Llama 3. We have Llama 3.2, correct? So that's why it thrown this error, but this error was not mentioned in the list of errors that needs to be retried. So that's why it didn't retry, but instead it just ran, and the exception block handled this error. So let's just retry this. Now we have put like 3.2 model, right? So this is completely random. Okay, it may be successful in the fifth attempt, or it may be successful in the third attempt, or it may not be successful anytime, or it may be successful in the first event, first iteration itself. Okay, so again, simulated socket timeout error. Request made it through the chaos. Okay, Llama runner process has terminated. Okay, let's just rerun this. I just wanted to show you guys this is completely random. Okay, so here the first attempt changed the response, right? Simulated 4 to 9 rate error. Now the error has changed. Second also API call, simulated socket timeout. So again, the error. In the third call, it is trying to attempt API call. I guess it will throw up an error saying unable to load the model. So let's just check. It's taking time. Okay, now I'm curious on like what's the response. Finally, the response came in. Okay, luckily our model got loaded and we have received a response. So what was our prompt? Why software testing important? Okay, the response is software testing is crucial for ensuring the quality, reliability, and performance and software application, and so many other stuffs. Right. So yeah, it did load the model. So now if I retry this, it would respond me like much faster because the slow start, the cold start, I said, right? So it has to load the model to GPU. That takes time. So now it's loaded. It should have responded like much faster. Let's just check if it responds. If we are lucky. The first one, yeah, error happened. The simulated error. The second one, same. Third one, same. The fourth one, socket timeout error, which is also simulated error. That's fine. The fifth call, yeah, it is successful, I guess, because it's taking more time, right? So this would take, usually LLM response should take like around 8 to 9 minutes, sorry, 9 seconds, as I checked, or maybe 2 to 4 seconds. That's it. So let's just check. Are you getting like what's happening here? Any doubts here?
No, no, no.
Navya?
No.
Are you understanding, right? It's like how I'm creating these errors.
Yeah.
So this random model allows me to like it allows me to do like so many. It may be choosing random words on the given words, or maybe
Mhm.
choosing a random number, random percentage. It allows me to do this. So with that, I'm trying to play around.
Mm.
So yeah. So here in the fifth attempt, we got the response. Okay. Luckily, our model is responding. Great news. Yep. So this is the difference between like creating a like let's just say prototype model, prototype application, and creating a production ready application, right? So yeah, we can definitely do this using while loop or let's just say with certain condition even in the for loop. No worries with that. But yeah, this enables us to do the things like in lot many easier ways, right? So we can specify whatever the errors we want to include or exclude. We can do like how much time we want to wait. We can could be it's very readable, right? Using this model, Tenacity. So that's what the importance of this model is. Sure then. So that was the agenda. This was the main concept I wanted to explain as of today. So any doubts?